Hey Chem fam, I'm Chelsea and welcome to the family, a space where we get to the heart of chemistry one level at a time. Let's dive in. In this video, we are going to discuss about molecules and ions, the very basic aspects of these two entities. All right, so we are going to compare it to a real life situation as usual so that it becomes easier for us to understand. All right, so a molecule is something like a social club, they like to stay together as a group, okay, happily as a group holding each other's hand. Whereas ions are entities which are either like a thief or a giver. If some of them, they steal the electrons from other entities, okay, or some which give away their electrons, okay. So based on that, there are two types of ions. The givers are known as the cations, okay, the ones who give away their electrons, gift away their electrons. The ones who steal other entities' electron are known as anions, the thieves. All right. So broadly speaking, molecules are like the social club, okay, where who prefer to remain in groups. So basically, they remain as groups of atoms that hold hands together. When I say hold hands together, it means they share their electrons. Okay. So here, a brief introduction of a term. When I say share electrons, means they hold their hands, means they have some kind of a bond. Okay. See, when we are in a group, like friends group, you share a bond with your friend, right? In a similar way, in case of molecules, when the atoms are in a group holding their hands, that holding the hands means basically they are sharing their electrons. Okay, we have discussed, we built the atom in previous videos, right? So you have seen, right? The atoms have the electrons. Yeah, so those electrons they share. When multiple atoms are forming a group, they share their electrons. So sharing means there is a bond. Okay, there is a bond. And to be more specific, in our chemical world, this bond is known as chemical bond, about which we will study a lot of things in the upcoming videos. All right. So molecules are the social clubs. They always prefer to remain in groups holding each other's hands. That is by sharing electrons. That is by forming the chemical bonds. Okay. And they are usually neutral, happy, and very independently existing species. All right. Whereas ions are of two types. Either they are the thieves. The thieves are known as anions. Okay. What do? They take away electrons from someone else. Or there is the another type, that is the givers, who are known as cations. What do? They gift electrons to others. All right. So this is the basic understanding that you need to know about molecules and ions. All right. Now we will take up each case, means each subtopic, that is molecules and ions, and study a little more detail about it. All right. Okay. So we are going to start with molecules. So what is the definition of molecule? Molecules are a group of two or more atoms which are held together strongly by some kind of attractive force, which is known as chemical bond. We just discussed chemical bond. So basically that is sharing of electrons. Sharing of electrons means there is an attractive force between those group of atoms. Okay, so molecules are a group of two or more atoms which are held together strongly by some kind of attractive forces, that is called as chemical bond. Now let us go to our virtual lab and get a visual picture of how molecules are, what are different types of molecules that we can have. All right, so we are going to first look at molecules of an element. Okay, then we will discuss molecules of a compound. So what are molecules of an element? Molecules of an element are one, two or more atoms of the same element existing as one species in three states. Of same elements, one, two or more atoms of the same element means, if suppose I am saying oxygen, so all that molecules means more about a group. So of the same element means the group consisting of atoms of the same element means all oxygen, like that. All right. So molecules of an element is one, two or more atoms of the same element existing as one species in the free state. All right. Now we will go to our virtual lab and see a few examples so that you get a clear picture of it. All right. So we are in our virtual lab. Now let's build some molecules of these elements. So the first case is diatomic molecules. Okay. Diatomic means two atoms are involved. Okay. So these atoms are of the same element, right? So we are going to first build hydrogen molecule. You have two atoms of hydrogen. Let's make oxygen molecule. All right. So this is a diatomic molecule with two oxygen atoms. Okay. Then let's try chlorine molecule. Here we have. So here you have a diatomic molecule where there are two atoms and both are chlorine atoms. Now let's visualize how do they look in three-dimensional space. So we start with hydrogen. You see, they are like spheres, right? Each atom is like a sphere. So when they form a group, they form a bond, a chemical bond. Now how does that look? You see, Can you see a line? A line is a way of representing the bond that they share, the chemical bond that they share. Okay, about which there is a lot of things to learn, which we will learn in the future. All right. So this is the bond that they share. So this is how a hydrogen molecule looks. So the line what you are seeing is an imaginary line. That is how we represent on paper. Okay, it's a way of illustration. Okay, so basically this is how it will be. Two atoms, they forming a bond. Two hydrogen atoms. Now let's see oxygen. You see that, do you see the difference in size also? You see the hydrogen atoms will relatively smaller, right? Keep observing, just let it sink in. Just keep observing as much as you can. You keep absorbing also. All right. With time, you will be very much used to all this. Okay. Since it's new, it may feel a little overwhelming, but that's very normal. All right. Yeah. So you see, let's see the bonds here. Oh, you see two lines are there. Two lines means there is two chemical bonds. Okay. Some atoms may have one bond, some atoms may have two bonds. Okay, so more bonds means it is more strong bond, means like if two are having one bond means they are just friends. If they are having two bonds means maybe they are best friends, like that. Okay, so the intensity, the strength, holding strength is more tight. Okay, so like that, the reason, details and all with time we will learn. Okay, so just understand and see and observe. Okay, so in reality how does it look? Something like this. Okay, now let's move on to chlorine molecule. Oh, do you see again, see, compared to oxygen, the sizes of atoms has increased. Why and all we will study in the topic periodic table. All right, let's see the bonds. So here you just have one line. I mean, there's only one chemical bond between the two chlorine atoms. All right. Okay, so this was all about diatomic molecules. Now let's see an example of triatomic molecule. Okay, can we move on to the triatomic molecule? Okay, so I'll show you one example. This is something a very interesting compound known as ozone. You would have learned about ozone when you discuss about global warming. Yeah, yeah. So this is what ozone is. A group of three oxygen atoms held together by chemical bonds. So let's see how they do. How do they look in 3 dimension? Will you see? Interesting, right? Now let's see the bonds. Okay. You see, there is kind of a one bond between two oxygen atoms and two bonds between two oxygen atoms, right? Well, the case of ozone is even more, little bit more complicated, which you will most cover in class 11. But as of now, this is enough. Okay, so this is how a triatomic molecule of ozone looks like. So you have a group of three atoms, and all three atoms are oxygen here. Okay, now uh, we saw a few examples. We built few molecules. We saw how they look in 3 dimensional space. We saw about the bonds and all that. All right. Now let's just quickly summarize it. Okay. So there is some special case, something like monoatomic molecules. Basically, actually, it's monoatomic. They are just cases where there is something known as noble gases. Okay. I have already in previous videos, when we were discussing how do atoms exist, we discussed that they exist as either free state, remember, or as molecules, or as ions. You remember? So it's more specific to say not include this here. So there are some elements which exist in free state as single atom, like helium, neon, argon. And why do they exist like that? That we will learn in the coming videos. All right. So now, since we are discussing about molecules, and to be specific, molecules of an element, let's just wrap it up. What all we observed? Diatomic, we observed what? H2, O2, Cl2, isn't it? In triatomic, what did you see? Ozone. Remember? Ozone. O3, right? Now there is a case of tetraatomic. Tetra means four atoms. So that is, for example, P4, phosphorus. Phosphorus exists as a group of 4 phosphorus atoms. Okay, then anything more than 4, a group of atoms of an element where the number of atoms in that group is whenever it is more than 4, we call it as polyatomic molecules. For example, S8. S8, sulfur. S stands for sulfur. So sulfur exists as a group of 8 sulfur atoms. All right. Now, I need to introduce you to one new term that is known as atomicity. What is atomicity? Atomicity is the number of atoms present in one molecule of the substance. So, how many ever atoms are there in one molecule of it? That is the how many ever atoms are there in one molecule of it? That is the atomicity. So, what is the atomicity of S8? It is 8. What is the atomicity of this? 4. What is the atomicity of this? 2. Okay, like that. All right. Okay. Now there is an interesting what to say case. I want you all to what to say go and search about it. That is something known as C60. C60. Search what its name is, and what is the atomicity of it, and what is it all about. It's just an extra activity. You can search it. It's very interesting. And more about it we will be discussing when we will be learning about carbon. Okay, the element carbon. Okay. Now let's move on to molecules of a compound. Okay, molecules of a compound are two or more atoms of different elements combined together in a definite proportion by mass. What comes to your mind when you read this expression? It is law of definite proportions, isn't it? Didn't we study about water, where hydrogen and oxygen combine to form H2O compound in the ratio 1:8 by mass? The same thing is what it is written over here. All right. So let's read it once again. Molecules of a compound, they are two or more atoms of different elements combined together in a definite proportion by mass to form a species that can exist freely of different elements. These are the keywords. Okay, so now let's go to our virtual lab and try to build some molecules of compounds. All right. Okay, so here we are in our virtual lab. So let's start building our molecules of some compounds. Okay, so we will start with diatomic molecules. Again, here what the difference is that in a diatomic molecule, you will have two atoms, but this time your two atoms will be different. All right, so let's make the first one, that is hydrogen chloride molecule. Let's see how it looks. You want to see that? You see? Visualize, just observe peacefully and try to let it sink in. Okay, so what do you observe? You see this white one, that's hydrogen. The green one, that's chlorine. You see the difference in size of their atoms. Very interesting, right? Why is this difference? That we will learn when we will be discussing the topic periodic table. All right. Now let's see the bond. Oh, so it's just one line, means there is one chemical bond, one bond between them, right? Okay, so let's build another diatomic molecule. This time we are going to build CO. What is that? Carbon monoxide. Let's see how it looks. First, we will see this one. You see, carbon and oxygen almost close. Their size is same, right? Keep observing, okay, and just keep observing and try to relate it when we will be studying about the different sizes of atoms, okay, or different elements. You see? So you know what? Actually, for time being, I'm just telling you. The orange one is carbon. This red one, sorry, whatever, orange, red, whatever that is, and the white grayish one is oxygen, the slightly bigger one. But they are quite same, right? Let's see the bond. Oh, there are three bonds. Interesting. First time you are seeing three bonds, right? Even that is possible. Okay. So this is carbon monoxide. Now let's move on to, this is two examples for diatomic molecules of the given compound, that is hydrogen chloride and carbon monoxide. Now let's move on to triatomic molecule. All right. We'll build triatomic molecule. So the safest, the simplest one, water. Let's build water. Here you have water. Let's see how it looks. We'll start with this one. You see the size difference. These two are, the white ones are hydrogen. The orange red one, that is oxygen. Any bonds? You see, there is one bond each that oxygen shares with each hydrogen. All right, interesting. Then we will build one more. What is it? Carbon dioxide. Let's see how it looks. You see, almost similar sizes. The center one is carbon. Let's see the bonds. Oh, see, this time the carbon has two bonds with each oxygen atom. Okay. Okay, now let's build, this is example for triatomic. Now let's build tetraatomic. Tetra means how many? 4. So let's take nitrogen this time. Okay, what is the compound? It's ammonia. It's called ammonia. Let's see how it looks. You see, the blue one is nitrogen, and you have 3 hydrogen. They are a group of 4 atoms. They are linked together by sharing electrons, which is known as chemical bond. So you see, each the nitrogen atom forms one bond with each hydrogen atom. All right, let's build one more molecule. What to make? Let's make this one. What am I making? Hydrogen peroxide. This is known as hydrogen peroxide, H2O2. Let's see how it looks. You see, 2 big oxygen atoms are linked. There is a bond between 2 oxygen atoms, and each oxygen atom has a friendship, a bond with each hydrogen atom. You see here, let's see the bond. Oh, you see, there is one bond between 2 oxygen atoms, and there is one bond, each oxygen atom has one bond with the two hydrogen atoms. Okay, by the way, just an extra information. This is a very interesting structure, you know. You will learn about it in the higher classes. It's very interesting. H2O2. The visual image, try to remember, keep it in your mind when you study about hydrogen peroxide in higher classes, particularly in class 11. Okay, you see in this format. Okay, fine. Now let's go back to our. Okay, so we were discussing molecules of a compound. We build few molecules. We build diatomic, triatomic, tetratomic, right? Now let's just summarize it. So diatomic, what all we build? HCl, hydrogen, chloride, then carbon monoxide. In triatomic, what all we build? Water, H2O, then carbon dioxide, CO2. Then in tetratomic molecules, what we build? Ammonia, NH3, then H2O2, hydrogen peroxide, right? Okay. So I think by now you understand what overall what a molecule is and how it kind of looks in three-dimensional space. You would have roughly understood what a chemical bond is. All right. What is diatomic molecule, triatomic molecule, tetratomic molecule? Okay. Fine. Now let's move on to ions. So what are ions? Ions are an atom or a group of atoms. It can be either a single atom or a group of atoms which carries positive or negative charge. So the givers are known as cations and they carry positive charge. We have already discussed. And the thieves are known as anions who steal the electrons from someone else. Okay. So let's just see few basic examples in our virtual lab so that you may understand it a little more. Okay. Fine. All right. So now we will see what ions are. Just I want to show you the cation, anion, why is that happening and all that. Just the basics. All right. We'll start with hydrogen. Okay. So you here see net charge. You charge meter. You keep noticing the charge meter as I make changes over here in the atom. All right. So now it says it's hydrogen. Just check the periodic table in the square box. What's it written? Hydrogen. It's hydrogen. It's a neutral atom. That's also given. And what do you see in the net charge meter? It's 0. Now, if suppose I remove this proton, you see that keep seeing the charge meter. Now you see plus one. What is written? It's positive ion. So it is a giver. It gave away an electron. So the charge is positive. It's high H. It is represented as H positive. It's a cation. All right. It's a cation. Okay. Now let's make a more complex situation. So we have oxygen nucleus. We are making oxygen. Okay. Now our nucleus is still unstable. So let's keep it stable. Okay, so it's oxygen. Okay, it's still positive. It's showing positive means in a giver state. Now it's a neutral oxygen atom. It's a neutral oxygen atom. Now you see, keep checking the net charge meter. I'm removing some electrons. Basically, suppose I'm taking these electrons and giving it to some thief has come and stolen, suppose 2 electrons. Positive, okay? Now instead, if suppose, what if oxygen itself is a thief? It goes and steals 2 more electrons from some giver. What do you see now? A negative charge. It's a negative ion, which is represented as O2 minus, 2 as superscript, O2 minus. That is an example of negative ion, which is known as anion. All right. So we saw H plus as an example of cation, where one of the hydrogen, the electron of the hydrogen atom was given away, and it became a positive ion, which is known as cation. Whereas oxygen, it is the thief. Okay, it took 2 electrons, stole 2 electrons from some species, and it acquired 2 negative charge. It's a negative ion, which is known as anion. All right, that is the basic that you need to know about ions, cations, anions, what exactly is happening, why are they called as cations and anions. Okay, as cations are the ones which give away electrons, the givers. You saw it in case of hydrogen, when 1 electron was given away, it became a positive ion, a cation, H plus. Whereas in case of oxygen, it is the thief. It stole 2 electrons from somewhere and got 2 extra electrons, and it can be, depending upon the cases, the number of electrons can vary, but the concept is stealing electrons and keeping it with itself. Okay, and it became a negative ion, and in this case it became O2 minus. Okay, fine. Now let's go back to our book. Okay, so I think by now you have understood the basic idea of what ions are. How do they behave? Basically, there are 2 types, cations and anions. Cations are the positive charged ones, okay, the givers, and the anions are the negative charged ones, the thieves. All right. Now Here's a challenge for you. Let's read it. A molecule of oxygen and a phosphate ion are both clusters of atoms. However, O2 is a neutral molecule, while PO4 3- is a polyatomic ion. What does the 3- sign on the phosphate ion tell us? Okay. So the first answer, the options are, it means that there are exactly 3 atoms in the cluster. It means that the whole cluster acts like a single unit with an electrical charge. It means that the ion is 3 times heavier than the molecule. It means the cluster is broken into 3 pieces. Well, using this question, I would like to explain it to you the concept of polyatomic ions. Okay, so you studied about H plus. We built H plus. We studied about O2 minus. Okay, but in all these cases, how many atoms were involved? This is an example of cation. This is an example of anion. How many atoms were involved in these 2 ions? 1, right? Now, the ions can also be polyatomic. Poly means more than 4 also. Okay, so for example, this one, phosphate ion, which is represented as PO4 3-. Now means PO4 means that is a single entity carrying a charge of 3-. Okay, it's a cluster of how many atoms? 4 oxygen atom and 1 phosphorus atom. Total 5 atoms are there, and they are a group together carrying a charge of 3-. So the answer for this question is, it means the whole cluster acts like a single unit with an electrical charge, and the charge over here in this case is 3-. All right. So I hope you are clear with the basics of molecules and ions. So see you in the next video.